pi again. Here we're at 5 pi over 4. This is 3 pi over 2. And here we have 7 pi over 4. Again, I don't want you to get into the habit of converting from degrees or from radians to degrees and going back, because you're introducing another step. You have to get into this habit of working through this. Now, I'm going to show you different ways of doing this. I have this memorized. I have the cosine and sine memorized for all of it. But I'm going to use special triangles in a lot of cases. We do want to talk about the unit circle. A unit circle is a circle of radius of 1 unit centered at the origin. So if we treat these all as unit circles with radius 1, there's a special property that comes out. And that is going to talk about cosine and sine. So if I want to talk about what is the coordinate point here of pi over 4, now I happen to know that is square root 2 over 2, comma square root 2 over 2. Again, those numbers should be familiar to you. I'm going to explain it in a second. When I have the unit circle, it has this property. You have an angle created anywhere starting anywhere on this circle. The coordinate points of the intersection of that unit circle and the terminal arm will be cosine theta, comma sine theta. This is the definite, or one of the things that the unit circle is very useful for. Here's the proof. Questions? By basic definition, Alexis, what is cosine in terms of your triangle opposite adjacent hypotenuse? Cosine is the adjacent over the hypotenuse. In our unit circle, okay, we have a radius of 1. This is our x coordinate, that's our y coordinate. So this would be x over 1 by substituting your adjacent and your hypotenuse. So the cosine is the how far over this point is from the x-axis, or from the origin, just by using basic trigonometric proof. Adjacent over hypotenuse on our unit circle, it could be any value. We're using values x and y. So we have cosine is equal to x. So you can substitute cosine theta, where we're talking about the rotation angle. Similar proofs for sine. Sine is opposite over hypotenuse. In our circle here, y is our opposite, 1 is our hypotenuse. Just get rid of the 1. So, using your special triangles, you don't have to remember this, but you do have to remember for other questions. Okay, if I say a point is at 1/2 and 1/2 and square root 3 over 2. What's the angle that created that? Well, I can tell you because I know that 1/2 is going to be cosine of the angle that created it. And sine will be square root 3 over 2 of the angle that created it. Sine of that angle will be square root 3 over 2, which we should know where numbers from our special triangles. Okay, so now let's go back to our special triangles. You can fill them out here, and then I would suggest that you fill them out on your purple sheet so it's nice and easy to find for you, so you can remember these. Now, there's a bunch of different ways, but we're going to basically start with a 45, 45, 90 triangle. Now, we also call this pi over 4, pi over 4, pi over 2. So here we're talking about how do I remember what the cosine and sine values for pi over 4 are. This guy doesn't help us. Okay? So if this guy is 2 units long, how long is this line? Do you remember? Well, using Pythagorean theorem, I have 1 squared plus 1 squared is equal to 2 squared. So I have 2x squared is equal to 4, x squared is equal to 2, x is equal to the square root of 2. The side lengths on this guy are square root 2. Now, is there another way to write this triangle? Well, I can have a hypotenuse of square root 2. What would the side length be if I have a hypotenuse of square root 2? I would have a 1. So, in this case, I like square root 2 over 2 because it has a rational number in the denominator. But sometimes it does make sense to have square root 2, 1 over square root 2 for sine. So now I can use my basic triangle definitions. Sine of pi over 4 is square root 2 over 2, or 1 over square root 2. Cosine or tangent of pi over 4 is square root 2 divided by square root 2, which is 1. So that's how I remember most of that stuff. Here we could use Pythagorean theorem again. Okay. So, well, there's a different proof. This is kind of a memorization one you have to deal with. If that is 1 unit long, how big is the opposite of 30 degrees? Derek, you wrote down these. How big, what size did you make this one here? I didn't do that. Okay. If your hypotenuse is 2 units long, the shortest side is 1 unit long. How long is the longest side? The side opposite the 60 degrees. Sorry, the longest leg. Square root 3. Square root 3 squared is 3 plus 1 squared, 1. So we have 4 is equal to 2 squared. So it does follow Pythagorean theorem. The cosine of 30 degrees is square root 3 over 2. The sine of 60 degrees is square root 3 over 2. Now, the other thing that you have to do with this triangle, you want to write our radian angles in there, and that's definitely not supposed to be there. 30 degrees is equivalent to pi over 6 radians, and 60 degrees is pi over 3 radians. So again, now we can get sine, cosine, and tangent of all of those using these special triangles. So cosine of 45 degrees, we've already said that, square root 2 over square root 2. I'm trying to misreading that, sorry. Cosine of 45 degrees is square root 2 over 2, or 1 over square root 2, depending upon which one you want. Sine of 45 degrees, pi over 4, same thing. Square root 2 over 2, or 1 over square root 2. Tangent of 45 degrees and pi over 4 is equal to square root 2 over square root 2, which is 1. Again, do you have to memorize those? No. If you have your special triangles, quite frankly, the first thing you should do walking into any trig test is write out your special triangles or diploma. Cosine of 30 degrees. The adjacent to 30 degrees is square root 3 over the hypotenuse of 2. Sine, 1 over 2. Tangent is 1 over square root 3. Now, is there another version of 1 over square root 3 that might show up? Going back again to last year, rationalizing the denominator, we could write that number as square root 3 over 3. And in some cases, it is necessary to do that. So cosine of 30 degrees could be either 1 over square root 3 or square root 3 over 3. You are going to have to remember how to rationalize the numbers. Cosine of 60 degrees is 1/2. Sine of 60 degrees is square root 3 over 2. Tangent of 60 degrees is square root 3. Again, all I'm doing is I'm going back to my special triangles and going opposite over hypotenuse, opposite over adjacent, or tangent, and so forth. Now, these ones are a little more important in that we cannot have them, we don't have them on a special triangle, they kind of have to be memorized. Okay, now if we go back to our definition of the x-coordinate of a point being the cosine value for that point. So if I have a circle, and I'm talking about 0 degrees, and this is a unit circle, what's the coordinate point for that one, right there? Well, it's 1 over and 0 up. So going to our definition for cosine, cosine is the x-coordinate of the intersection of the terminal arm and the unit circle. So cosine of 0 degrees or 0 radians is 1. Sine of 0 degrees or 0 radians, well, what's the y-coordinate of that point? It is 0. So sine of 0 degrees is 0. Tangent, well, tangent is opposite over adjacent. Well, it's not really a triangle, but our opposite would be 0 units, and our adjacent would be 1 unit. So tangent of 0 degrees is 0. We can do the same thing for the point up here. It has a radius of 1, so this point is 0, 1 at 90 degrees. So cos of 90 degrees is 0, sine of 90 degrees is 1. Here's where the problem comes in. Not a problem so much. If we think about tangent being opposite over adjacent, really have, our opposite is 1. I know it doesn't work. But our y-coordinate is 1. Our x-coordinate is 0. What happens when you divide 1 by 0? It is undefined. So tangent of 90 degrees or tangent of pi over 2, there's no real number for that. It's undefined. And we do that exactly, we say just undefined. Now, here's where we're getting to something new. Last year you talked about sine, cosine, and tangent, the 3 basic trigonometric ratios. There are 3 other ratios that we are going to use in this unit and throughout the trade, and they are called the reciprocal ratios. Okay. Now, they are somewhat hard to remember sometimes. They're nice, they're given to you on your formula sheet, but I got through high school remembering there's 1 C per pair. In other words, they start with a C. Only one of them starts with a C in each pair. So cosecant is the reciprocal of sine theta. So that's the definition. Now remember, that one starts with a C, sine starts with an S. Secant is the reciprocal of cosine theta. Starts with an S, starts with a C. Cotangent theta, well, it's right in the name. It is the reciprocal of tangent. So those ones are given to you on your formula sheet. What the definitions for those reciprocals are. Now, tangent is opposite over adjacent. The reciprocal of opposite over adjacent is adjacent over opposite. So another definition, which isn't given to you on your formula sheet, is your triangle definition for cotangent. Cosine is adjacent over hypotenuse. Secant is going to be hypotenuse over adjacent. Again, the definition is flipped. And correspondingly, you have sine. Sine theta is equal to opposite over hypotenuse. Cosecant will be hypotenuse over opposite. Okay. Now those are going, because I'm going to be asking you questions dealing with the trig ratios. Lots of different ways, etc. Now if we go back to our special triangles, we don't have to memorize anything off our special triangles if we know the definition. So we have, if I wanted to know cotangent of pi over 6. Tangent is opposite over hypotenuse. Cotangent is its reciprocal. So cotangent of pi over 6 would be adjacent over hypotenuse, or 3. And if I wanted to know cosecant of pi over 4. Cosecant, okay, so cosecant is the reciprocal of sine, opposite over hypotenuse. Well, cosecant is going to be hypotenuse over opposite, so I could write it 2 over square root 2. But in this case, this is one of the reasons why I like having that second set of numbers here. If it's hypotenuse over opposite, it is just written, it's easier to write it as square root 2. So I'm going back to using my special triangles and adding 3 new trig definitions within them. That way you don't have to memorize all those other stuff. Now, cast rule. Again, what does cast stand for? Well, it stands for cosine, all, sine, and tangent. Where does the C go in cast? Quadrant 1, 2, 3, or 4? You are going to start it in quadrant 4. And we're going to use the cast rule. Now, what does the cast rule tell you? It tells you which trig ratios of the primary trig ratios are positive in those quadrants. Cosine is positive here, the other two are negative. All are positive here. Sine is positive in quadrant 2, cosine and tangent are negative. Tangent is positive here, sine and cosine are negative. Would cosecant be positive here? Cosecant is the reciprocal of sine. If sine is negative, Cosecant will also be negative. So we can apply the other three trig ratios by understanding CAS. Okay? So we can also think about starting in quadrant 1, add sugar to coffee. Don't forget the quadrants are 1, 2, 3, 4. We have in the past made mistakes with that. So. Now here's the thing. I'm going to use my understanding of CAS rule, reference angles, and my special triangles to do this. Cosine of 135 is over here. Cosine of 135 has a reference angle of what? Yes? So our reference angle is 45 degrees. So I'm going to go to my 45, 45, 90 triangle. Cosine is adjacent over hypotenuse, so we're going to go square root 2 over 2. And then I'm going to ask myself, what is cosine in quadrant number 2? Positive or negative? What's the only thing positive in quadrant number 2? Sine. So cosine is negative. So the cosine of 135 is negative square root 2 over 2. I found my reference angle is 45 degrees. I use my understanding of special triangles. And, I got to deal with negative signs also. Sine of 135, we get the same square root 2 over 2. But sine in quadrant 2 is positive. And tangent of 135 would be square root 2 over square root 2. So tangent of 135 numerically is going to have a value of 1. Sine's the only primary trig ratio that's positive in that quadrant. So tangent is going to be negative 1. Cannot get in the habit of using your calculator. Yes, if you go tangent of 135, it will give you negative 1. But if you punch in cosine of 135, it's going to give you negative 0.707 ... Okay? You do have to know your exact values. 4 pi over 3. Okay, well, there's 3 pi over 3. 4 pi over 3 would be down there. What's my reference angle for 4 pi over 3? Well, I go to pi, I add 1 more pi over 3 to get to my 4 pi over 3, so my reference angle is pi over 3. So I'm going to use my 30, 60, 90 triangle. So pi over 3 is the larger angle here. Again, I'm just using the one in my head. Use one in front of you. We have adjacent is 1, the hypotenuse is 2. Is cosine positive or negative in that quadrant, Sean? So cosine of 4 pi over 3 is negative 1/2. Sine of 4 pi over 3, numerically, from my special triangle, I pull square root 3 over 2, opposite of the pi over 3, square root 3. Sine in that quadrant is also negative, so I have a negative square root 3 over 2. And finally, tangent in that quadrant is opposite over adjacent, square root 3 over 1 for my special triangle. In that quadrant, tangent is positive. (11 pi over 6). Well, that's almost all the way around over here. I go 6 pi over 6. If I go all the way around, I get 12 pi over 6. I have a reference angle of pi over 6. Going to my special triangle, pi over 6 tells me my cosine would be square root 3 over 2 for my special triangle. I'm in quadrant 4. Cosine is positive in quadrant 4. That's good. Sine of 11 pi over 6, so I'm going to my triangle. What is sine of pi over 6? Well, that's 1/2. The opposite over the hypotenuse. Down here, a little sine is negative. If we go back to our definition, where sine is equal to the y coordinate of the point on a unit circle, you can see why it's negative. It's below the x-axis there. And tangent is 1 over square root 3, 1 being the opposite, and square root 3 being the adjacent. But we are in this quadrant, so tangent is negative. Oops. Get me off. Now we can do the same thing for secant. We're going to use our special triangles. 300 degrees is down here between 270 and 360. I end up with a reference angle of 60 degrees. My special triangle for my 30, 60, 90 triangle. Secant is the reciprocal of which ratio, Aurora? The reciprocal is cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that guy is equal to 2 over 1. Since it is the reciprocal of cosine, it's in this quadrant. Quadrant 4 cosine is positive. So positive 2. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. Opposite is square root 3, but we don't want sine, we want secant, so I want hypotenuse over opposite. 2 over square root 3. Sine in the fourth quadrant is negative, therefore cosecant in the fourth quadrant is negative. And you will see this guy written 2 square root 3 over 3. Multiply both top and bottom by square root 3 for that. We perform the same thing for that. I'm going to skip E. I want to get over here to F. 3 pi over 2. That's down here. So my reference angle is 90 degrees. I don't care which side you're working on. That's 90 degrees. Or pi over 2 units. Radius. We don't have a special triangle that we can use 90 degrees for. We have to go back to our memorization. Now, this point down here is 0, negative 1. Okay. So the cosine value for that point is the x coordinate. We've got secant. Okay, well, secant is the reciprocal of cosine. What's the reciprocal of 0? 1 divided by 0. Uh-oh. Can you divide by 0? This guy, secant, there is undefined. Okay, because because we have that 1 divided by 0, the reciprocal of 0 is undefined. We have cotangent. Well, cotangent is going to be equal to adjacent over opposite. So in this case, 0, our x-coordinate, divided by our y-coordinate. 0 over -1. We do have a cotangent value for that. I'm going, oh, for Pete's sakes. Okay. Think about this being your adjacent, that being your opposite. And then for tangent, we would have -1 divided by 0. Again, we have your undefined. Those cardinal points, those are the ones that I actually think that you probably should memorize. Okay, so you should know, well, we already talked about what the cosine and tangent would be. So we should know pi over 2, pi, 3 pi over 2, and 0 and 2 pi. And all I'm doing with that is using my cardinal points and our triangle definition. Because that point there was 0, -1, sine is opposite over hypotenuse, -1 over 1. That's how I get my sine. Take the reciprocal of cosine. Cosine is 0 over 1, so cosine would be 0. The reciprocal of cosine is secant, 1 over 0. That doesn't work, that's undefined. I may not get to what I need to do. Now, let's talk about solving triangles. Solving angles. Again, with these ones here, you should be able to do them, you are able to do them without your calculator. Okay? Cosine theta is equal to -1/2. And I tell you the quadrant between pi and 3 pi over 2. So I'm talking about something in that quadrant. Now, forget the negative. Go to your special triangle. Where is cosine equal to 1/2? Forget the negative. Where is cosine equal to 1/2? It's equal to pi over 3. Adjacent, hypotenuse. So I end up, what I found here is I found a reference angle of pi over 3. How big is that entire angle? Yes? It is equal to pi plus pi over 3. I had to get the pi, and then I had to go a little bit further. So you found your reference angle by getting rid of that negative sign. And I told you what quadrant it was in, that's why we were able to find that, and using our special triangles. Now, sine is equal to square root 3 over 2, and cosine is less than 0. That's what that stands for. So I'm asking you, which quadrant is sine positive and cosine is negative? Yes? So we're over here somewhere. Using my special triangle, where is sine square root 3 over 2? What angle gives me sine square root 3 over 2? Opposite over adjacent, so again, we have a pi over 3. But I'm actually asking you for the size of that angle there. I gotta go all. I have to go all the way to pi and back up pi over 3. So my angle is going to be pi minus pi over 3. My rotation angle from the positive x-axis is 2 pi over 3. Again, I didn't develop an equation. I used my visual diagram. The only thing different than what I'm doing here from last year is I'm not using degrees exclusively. I'm using radians, which makes it a little easier, a little more difficult to work with. Why is this freaking board driving me nuts? So we have secant is equal to 2 and tangent is less than 0. So secant is the reciprocal of cosine. So where is cosine positive and tangent negative? Which quadrant? Yes? We're down here somewhere. Okay? I don't know what that angle is. We're looking for this angle, but we're able to find that angle there by talking about secant is equal to 2. So now we're going to stay speaking radians, so we're going to say this is going to be pi over 6, pi over 3. Secant is equal to the reciprocal of cosine. So that would be hypotenuse over adjacent. Hypotenuse over adjacent is pi over 3. So our reference angle is pi over 3. Our rotation angle is all the way to 2 pi and back up. So 2 pi minus pi over 3, 5 pi over 3. Now, the next one, sine is less than 0 and tangent is undefined. Well, which two quadrants, Sean, is sine less than 0? So we're looking down here. Tangent is only ever defined on either this point or this point up here. So since we're talking about between quadrants 3 and 4, we're here, tangent is undefined on the x or on the y-axis. So theta in this case is 3 pi over 2. And this is one of the ones that is a memorization part. Yes? Oh, sorry, sine is greater than. Yes, it is. Brain freeze. I'm just going to change that to negative. Change that sign direction so I don't fix the mistake I made. Okay. I'm going to do these last two questions, and you will have homework for tonight. The terminal line of angle theta intersects the unit circle at a point negative or 0.819 and negative 0.574. Now, there's the unit circle. They're going to be down here somewhere. Because we have to be quadrant 4, positive x, negative y. What is the angle theta? Well, here is the angle theta that we want. This is where you get into this understanding of each one of those points tells you something in trig. The first coordinate tells you the cosine value. The second coordinate tells you the sine value. Because it's an intersection with the unit circle. Different point if it's not the unit circle, but. Okay. Now, how do we determine this? Well, we know cosine, and I'm going to use cosine theta because it's the easiest one. I'll do sine theta in a minute. We do not have a special angle that has 0.819. I have no idea what that angle is. So I'm going to have to use my calculator. I'm going to ask you to turn your calculators into radian mode, please. I would say all of you are in degree mode right now from trig or from physics. So turn your calculator to radian mode, go mode, which is next to the second function button, and highlight radian, please. Now again, I'm speaking radian because I don't want us to get used to it. We should have an angle less than 1, or sorry, yeah, an angle less than 1 radian. Chloe, what did you get for that? 0.611. Okay, now that's not quite our answer because what our calculator gave us was our reference angle. I want my reference angle, I want my actual angle. So that would be the angle theta would be equal to 2 pi minus 0.611 5.6 something or other. What did we work out? What did that work out to be? Yep. Thank you. Okay. So that gave me my reference angle. Now, I could do the exact same thing with sine, but I have to be careful. If I want my reference angle, oh, for Pete's sake, I'm going to drop the negative sign. I want my calculator to tell me the reference angle between 0 and pi over 2 or 0 and 90 degrees, depending on which angle I ask. So when I talk about this, my reference angle is equal to the inverse sine, and we're going to get the same answer. Okay? You're not going to get a different answer because that sine and cosine will give you the same. Just drop the negative sign whenever you're punching it into your calculator and you want the reference angle. Because I don't want negative 0.611. That's not a reference angle. That's a rotation angle. There is your homework. I will do that other question tomorrow.